Casting or type conversion in Java. Generally, in programming, you have two groups of casting or type conversion. Implicit casting or implicit type conversion and explicit casting or explicit type conversion. What is implicit casting? Implicit casting is done automatically by the compiler. It happens because there is no chance of data loss. Here I prepare some stuff to save times. So byte can be converted automatically to short. Short can be converted to integer, and integer can be converted to long, and long can be converted to float, and then float can be converted to double. Why? Because the size of byte is less than short, the size of short is less than integer, the size of integer is less than long, and so on. So there is no chance of data loss. The compiler does it automatically. But you as a programmer should be aware of this, because in some cases that makes difference and you get the wrong result for your calculation. What is explicit casting? Explicit casting is done by the programmer manually using brackets. You use brackets and the name of your type before the name of your variable or the value. Implicit typecasting and explicit typecasting happen only between compatible types. So even if this happens automatically by the compiler, it happens between compatible types. So byte, short, integer, long, float, double, they are all numbers. Explicit casting is useful when you know that there is no chance of data loss and you convert backwards. For example, you convert integer to short, you convert float, you convert float to long or float to integer when you know the range of your number. Integer x, let us say 2, double y x plus 5, for example. This is an example of implicit typecasting. So here the x is not integer anymore. So the compiler converts the x to double and then plus 5, and then 5 is also double, and then the result is stored in this variable y. Let us see y Java casting. Now you see here 7.0. This is a decimal value, a decimal number, and the casting happened automatically. If we bring a little change here, let us make this double and this one integer. Here we see an error. The reason is because the size of double is much larger than the size of integer, so there is chance of data loss. It says type mismatch cannot convert from double to integer. In integer type you can store only up to 2 billion, and in double you can store much larger number than 2 billion. And if you have, for example, 3 billion in this double, you will lose 1 billion, and that is the reason the compiler gives error. Now the compiler is not that smart to notice this, that now x is double but it is 2, and 2 is in the range of integer, but in some case x can be 5 billion, 10 billion, 100 billion, and then if you try to convert that automatically, if you let the compiler to convert that automatically to integer, then you will lose data. It will cut your data, and then you will say like half of or less than half of your data. So any value of integer can be stored in double, but double cannot be stored in integer because it has a larger size. It has a much larger range. Let's bring it back. Integer, double. What actually happens under the hood in this situation is that we see this as programmer as x. You see, okay, this is this integer variable, but at this line this is not integer anymore and this is not x. The value of this variable is now stored somewhere in the memory as an anonymous variable without any name, without any identifier, just with value. The value of the x is stored somewhere in the memory as anonymous variable converted to double. So this is the value is converted to double and is stored somewhere in the memory. Then the calculation happens and the result is stored in this variable y. And the same thing happens to 5. Even if this is not a variable, this is a direct number, but this is an integer. So the compiler converts this to double, stores somewhere in the memory, and then the same thing that happens to x, also to 5, and the compiler calculates the result and stores in a double variable. Now let's do an example of explicit casting. Change this back to double and this one back to integer. So now you see error. To avoid this error and you are sure that the range of this number is not higher than the range of integer, you can tell the compiler, I am sure there will be no data loss. Then you say integer. You explicitly, manually, wisely tell the compiler to convert this to integer. And now it is an integer. So 7 instead of 7.0. When this was a double, and this was an integer, x was 2.0, it converted and stored somewhere else, and it also converted 5 to double, and it is 5.0. So 2.0 plus 5.0 was 7.0. This was type conversion between compatible types, between numbers. And it is very important that you know that when you work with web application, with applications, with user interface, the inputs are always a string. You get always string from user. So in that situation, you must convert a string to number. And for that, you have here classes, libraries to help you. As an example, let us say string age, and the user enters like 30. And that's what you get from the user interface. Always string. Even you see it as number, but it is a string. So to convert this to integer, you have a library, integer age as number, then you have integer class in java.long, then you have parse int takes a string as argument and converts that to integer. Now let us see age as number is 30. In this example, age is an integer. In some case, you get float, you get double, you get any other type data. You can convert them the same way. Let us say that this is a double. Now this is not age, let us say salary. For example, 3000.99. And then because this is a double, you have here also double class, double dot parse double. Cannot convert from double to integer. Okay, this one should also be double. Now this way you can convert to double, double, parse double. You have float, float, parse float. And then because float is also decimal, it can be stored in double, but the range of double is much higher than floaters, so you also should change this to float, and it returns automatically float. You don't need to add an extra if here it is not necessary. So the same way you have for short, parse short, and then it must be short as well. So you got the idea. That is very necessary and very important to know. Let me recap very fast. Implicit type happens by the compiler automatically when there is no chance of data loss. Explicit casting happens by you manually when you are aware of what you are doing. When you know that there is no chance of data loss, you do it yourself manually. If you do it without knowing what will happen, you will lose some data. Let me give you an example. We want to convert from integer to short explicitly. 1, 2, 3, and this number. In short, you can store up to 32,000. So y, we say x, let us print y. You see now this value. This is not this value. There is no problem. Now it is 1000. Let's make it this 12,000. It will be still okay. Let us make this in the range of 32,000. 32,000. You see 32,000. Let us say 32,001. It is still okay. Make it 33,000. Now we see something else. We don't see this number. If you change this to something like 93,000, you see in this value. So this is the reason why automatic casting does not happen from a type with larger range to a type with a smaller range. If you do it manually and your number is much larger than the range of the type that you are converting to, you will lose data. We talked about converting string to number. For example, if it is integer, you use integer. If it is double, you use double. If it is float, you use float. If it is short, you use short. But now the compiler does not give any error, or the tools does not show anything that there is anything wrong with this. But if you compile your program, you see error because this is double. For the compiler, this number is double, and we try to convert this to integer. So it is exception in three main Java number format exception. So for input string, this number 72.5. So the error is number format exception, which means that it cannot convert from double to integer. If we change this to double and then parse double, and then here you use explicit casting to integer, it will be fine. 72. So when you convert from double to integer, it always removes the decimal point. If it was like 5987, let us you see 72. So this explicit casting converted double to integer, so the compiler removed all the digits after the decimal point.